Hello, dear friends. This is Srinivasan, who is having more than 30 years' experience in this construction industry, trying to give you a small presentation on ultrasonic bulk velocity test based on ASTM C59707. This is the equipment which has been used for ultrasonic velocity set. This is the image of the ultrasonic tester. Test methods. This test method covers the determination of the velocity of the longitudinal stress wave pulses through the concrete. This test method does not apply to the other types of stress waves through concrete. The values stated in SI units are to be regarded as a standard. No other units of measurement are included in the standard. The standard does not address all the safety concerns, if any, associated with its use. It is the responsibility of the user to establish appropriate safety and health policies to determine the applicability of the limitation prior to use. Introduction. Concreting is a complex material which begins its life as a mixture of a graded stone aggregate particles suspended in a fluid of cement and water and admixtures. Normally, aggregates occupy 75%, cement about 15%, and water content 10%. The priority when choosing a mixed design is strength, which along with the permeability of the concreting is governed by the water-cement ratio. For high strength and low permeability, the water-cement ratio should be low. It is usual for the coarse aggregate used in the concreting to have a nominal size of 20 mm. Concreting reaches its strength after about 3 days and 90% after 28 days. Concreting is very versatile, potentially durable composite material, which is strong in compression but about 90% weaker in tension, such that structural members subject to tensile stress are reinforced with steel bars. The setting of the concreting is not drying out a process but a chemical process which is known as a hydration, where the calcium silicates in the cement reacts with the water to form hydrates and accompanied by the evaluation of the heat. In the early stage of the hydration, water rises and aggregate settles, such that the surface concreting is not representative of the overall volume. The structure of the cement hydrate to a large extent determines the durability of the concreting. There are inherent process of a new neutron per mm and pores 50 to 100 times larger as a result of the presence of excess water above that required to complete the hydration. Additionally, there may be air pockets or volumes or lower density due to inadequate compaction. It is also likely that all concreting has extensively crack system induced by a shrinkage, thermal movements, loading and number of other causes. Concreting is a service is exposed to a wide variety of environments, and because of its physical and chemical nature may be deteriorate as a result, which has been stated by Perkins in 1997. The pores in the crack system provide passageways by which acidic moisture and gases that attacks the alkaline concrete can penetrate. Once the deterioration is apparent, its classification and extension need to be examined and remedial has to be specified. Routine testing of concreting is primarily concerned with assessing concreting adequacy and future performances, stated by Bangri and Millard in 1996. An initial visual inspection of the site can prove valuable of locating a deterioration and the aid of a choice for the test. Although standard control cubes and cylinders are used to determine the strength of the concreting, they cannot be truly representative of the in situ concreting strength of a structure. However, extraction of the cores is expensive and might weaken the structure. Various NDE methods which enable certain properties of a concrete to be measured in situ, from which concreting strength is estimated, have been devised. Of the non-destructive techniques, the ultrasonic pulse velocity technique offers the lowest cost and convenient as well rapid to employ. Materials and methods. Ultrasonic pulse velocity. When the surface of the semi-infinite solid is excited by the time varying a mechanical force, energy is radiated from the source as there is distinct type of elastic wave propagation. The fastest of these waves has particle displacement in the direction of the travel of the disturbances and is called longitudinal compression or a P wave. The compression wave velocity Vp is a function of the dynamic Young's modulus, which is known as a E, the Poisson's ratio known as a V, and the mass density P, that is Krug-Kumar and Krug-Kumar, 1969 March 2000, and is given by V by P is equal to root of E1 minus V divided by P 1 plus V into 1 minus 2V, all closed. UPV, mass versus concreting quality. Above 4500 is excellent, 3500 to 4500 is good, 3000 to 3500 is a medium acceptable level, below 3000 is doubtful. It is clear from the above equation that velocity is independent of geometry of material and depends only on elastic properties of the material through which it passes. Hence, the principle of assessing the quality of concreting is that comparatively higher velocities are obtained when the quality of the concreting in terms of density, homogeneity and uniformity is good. In case of poorer quality, lower velocities are obtained. Types of test. There is a direct method which has been shown here. Semi-direct method has been shown this message. Indirect method. In the test described in British Standard 1881, Part 203, BS 1881-1986, the time the pulses taken travel through the concreting is recorded, then the velocity is circulated as V is equal to L by T, where V is the pulse velocity, L is the length in meter, and T is the effective times, which is measured time minus the zero time correction. The zero time correction is equal to travel time between the transmitting and receiving transducers when they are passed firmly together. The pulse velocity in concreting may be influenced by path length, lateral dimension, presence of reinforcement steel, moisture content of the concrete. The influence of the path length will be negligible provided it is not less than 100 mm when 20 mm aggregate is used, or less than 150 mm for 40 mm size aggregates. Pulse velocity will not be influenced by the shape of the specimen, provided its lateral dimension, that is, its dimension measured at right angles to the pulse path, is not less than the wavelength of the pulse vibrations. For pulse of 50 Hz frequency, this corresponds to a least level dimensions of about 80 mm. The velocity of pulses in steel bar is generally higher than they are in concrete. For this reason, pulse velocities measurement made in the vicinity of reinforcement steel may be high and that is not representative of the concreting. The influence of the reinforcement is generally small if the bars runs in a direction at right angles to the pulse path and the quantity of the steel is small in relation to the path length. The moisture content of the concrete can have a small but significant influence in the pulse velocity. In general, the velocity is increased with increased moisture content, the influence being more marked for lower quality of the concreting. Uses. The UPVSS can be used to check the uniformity of the concrete, to detect cracking and voids in concrete, to control the quality of the concreting and concreting products by compromising result to a similar made concrete, to detect the condition and the deterioration of the concrete, to detect the depth of the surface crack, to determine the strength of the previous data available. Procedures. Ultrasonic equipment includes a pulse generation circuit consisting of electronic circuit for generating pulses and a transducer for transforming electronic pulses into mechanical pulse, having an oscillation frequency in the range of 40 kHz to 50 kHz and a pulse repetition circuit that receives a signal. The transducers, clock oscillation circuit and power sources are assembled for use. After calibration to a standard sample of a material with known properties, these transducers are placed on opposite sides of the material and recordings are noted. Thank you for watching this presentation. Kindly subscribe, like and share, which will motivate me for a further good presentation. Do not hesitate to ask me for any clarification, which will be responded at the earliest conveniences. Contact me at civilconclave@gmail.com or at my Telegram group, Ask Srini at the Telegram groups. The link has been provided below. Thank you for watching this presentation. Kindly subscribe.